Hello physical science student, welcome to video 7 of atomic structure, and we're going to go through the key groups of the periodic table. Last lesson we got introduced to the periodic table, and so this video we're going to just go through the key groups, not all of them but the key ones. Let's see if this works. Okay, first group will be group 1, which having your periodic table handy at the moment might be a good idea, because you'll be able to pause and just have a look every now and again what we're talking about. But they're the most left hand side group, and these guys are called the alkali metals because they react with water to form what are called alkaline solutions. They generally have low melting points and low boiling points. Remembering, of course, why we group these guys all together, because they have similar chemical properties. They don't have the identical chemical properties, but they have similar chemical properties. And remember that that relates to the number of electrons in the outer shell, and we're talking about group 1, so these guys all have 1 electron in the outer shell, and so they will have similar chemical properties. The densities are so low that they float on water, and they are so soft they can be cut with a knife, even though they're metals. They are very reactive and must be stored underwater to prevent them from reacting with oxygen and water vapor in air. And so some examples of those will be sodium and potassium, and on our OneNote and in class we'll see a video where some of these group 1 elements are exposed to water, and they'll blow up basically because they react with the water to produce a lot of hydrogen, and the hydrogen then blows up. And it's the reason that we won't actually be using much of these guys in the science laboratory. I think in one prac we use a little bit of sodium, and so you'll get to see that sodium reacts with water, but otherwise they're just too dangerous to use, and you'll see in the video why they're regarded as so dangerous. And this is just the link to remind me to show you a video, or to remind you to go to your OneNote and have a look at the video. The group 2 elements, the next one along, starting with beryllium on the top, are called the alkali earth metals because they were first extracted from oxides within rocks, and that's why. Because many years ago, when people were looking at this stuff, they were all extracted from things you could get out of rocks basically. They are less reactive, so less explosive. Examples are beryllium and magnesium. Next group is, we jump all the way across, remembering we're only looking at the groups that have either special names or special reasons, and we're jumping across to the second last one on the right hand side, which are called the halogens. So you might have heard about halogens because you might have halogen lights. If you've got a floodlight, it's probably a halogen light. Nowadays most car headlights are halogens. These elements are so reactive that they never occur freely in nature, so you have to actually extract them from other things. They're very active because, being group 17, they actually have 7 electrons in the outer shell, and therefore they want to gain another electron, and they do that by reacting with other things. They often combine with different metals to form salts, remembering that group 17 is over on the right hand side of the periodic table, so they're going to be non-metals, but they will combine with metals to make salts. Examples are chlorine and iodine. And the last group we're going to look at probably is group 18, which are right over on the furthest right hand side, and these are the noble or inert gases, and basically they'd be called noble or inert because they don't react with things. They have full outer shells, and so they're quite happy not to react with other substances. And in fact, to get them to react with other substances you have to put in a lot of energy. They're all colourless gases at room temperature with low melting points and boiling points, so at room temperature they'll be a gas. They exist as separate atoms, they don't even have to join with each other, so if you have something like neon or argon, they're just atoms bobbing around, whereas when we're talking about other gases like oxygen and hydrogen, oxygen is 2 oxygens joined together, and hydrogen will be 2 hydrogens joined together. So just remember that as well. A couple of examples. Now the other thing that we need to know in the periodic table are the periods, which are basically the horizontal rows, and these are also numbered. Now they number them from 1 down, and although this one, the one in your information booklet, doesn't have the numbers for you, if you look in your textbook, the periodic table in your textbook has the numbers there for you. The period number represents the number of occupied electron shells, so that's a handy thing to know. If you've got to draw an electron diagram, you can just work out the period number of the element, and that will tell you how many shells you have to draw. And the elements in the same period share a gradual change in their physical and chemical properties. So previously in groups, we've said they've all got similar chemical properties. So conversely, if you go across, what there is a gradual change in chemical properties from being metals to being non-metals. And in the next video we're going to actually look at periods a bit more, and then we're going to look at metals and non-metals a bit more as well. Cheerio!